Okay, in this video, we will be discussing about the continuity of a function at a point. So a function is continuous at a point if by drawing the graph of the function, the point in question will be traversed without any interruptions. So you can just go smoothly, you can just traverse the graph or the point in question. So there will be no interruptions. So if that is the case, then the function is said to be continuous at that value. Let's say, for example, this function f of x given the graph of f of x equals x minus 1. Is this function continuous at x equals negative 2? So where will you look? X equals negative 2 is here, so this part of the function. So from the left of that, going to the right, are there any interruptions? No, you can just go smoothly. So this function is continuous at x equals negative 2. How about at x equals 0? Where is x equals 0? X equals 0 is here, so this part of the graph. So the function here is continuous because you can just go from the left to the right passing through x equals 0. So this function is also continuous at x equals 0. How about at x equals 2? At x equals 2 is this one here. So this part of the graph, x equals 2. So it's also continuous there. At x equals 3, in this part here, so here, it's also continuous there. Actually, if you will have any value of x, the function is still continuous. So this function is continuous at any value of x because this has no interruptions. You will have no interruptions if you pass through that value of x. How about this one? We have here a line with a hole and a point here. So this is the equation of the function. It's a piecewise function, x minus 1 or y equals x minus 1 if x is not equal to 2. And it's y is 3 if x is equal to 2. So this part here. At x equals negative 2, where is x equals negative 2? This one. So this part of the graph. Will you have any interruptions if you will pass this part? No. So this is a continuous function at x equals negative 2. How about at x equals 0? Where is x equals 0? This part of the graph here. So no interruptions if you pass there. So the function is continuous at x equals 0. How about at x equals 2? Here, x equals 2 is this hole here. So if you cross that from here going to the other side, you're going to pass through a hole. So there's an interruption here. There's a hole. So this function is not continuous at x equals 2. How about at x equals 3? X equals 3 is this part of the graph. So no interruptions. So this function is continuous at x equals 3. How about this function? Okay, we have two parts here, this line here and part of a parabola. So if that's the equation, or I mean, if that's the graph of the function, is the function continuous at x equals negative 1? Where is x equals negative 1? It's this part here. So are there any interruptions? None. So this function is continuous at x equals negative 1. So yes. How about at x equals 1? X equals 1 is here. So if you cross or if you will pass through that value of x from the left going there, and then you will jump here. So and then go there. So there's an interruption, there's a hole, and there's a jump. So at x equals 1, the function is not continuous. So no. How about at x equals 2? X equals 2 is this one. So this part of the graph. So the function is continuous at x equals 2. How about at x equals 3? X equals 3 is this part of the graph here. So the function is also continuous at x equals 3. So yes. How about this function? Okay. So we have here 1, 2, 3, 4 parts of the graph. Is the function continuous at x equals -2? Where is x equals -2? This part here. So can you cross that without any interruptions? Yes. So the function is continuous at x equals -2. Yes. How about at x equals -1? X equals -1 is here. So will you have any interruptions if we will cross that? Yes, because this one is asymptotic to x equals -1. It cannot pass through -1. And then from here, there's like a jump. So this function is not continuous at x equals -1. So no. How about at x equals 0? Where is x equals 0? This part here, the y-axis. So this part here of the graph, can you pass that without any interruptions? Yes. So this function f of x is continuous at x equals 0. Yes. How about at x equals 1? At x equals 1, it's this part here, so you will have a hole. So if there's a hole, that is not continuous at that point. So the function f of x is not continuous at x equals 1. So no. How about at x equals 2? At x equals 2, this part here, so obviously there will be an interruption. So no. At x equals 4, at x equals 4 is this part of the graph. So yes. So that is it. If you are given with a graph of the function and you are asked to identify if the function is continuous at the given value of x or not. How about if the graph is not given, just the equation of the function? We need to check the three conditions. What are these three conditions? So the three conditions of continuity are these. Number one, f of c exists. So if a function is continuous at x equals c, or for it to be continuous, f of c must exist, and the limit of f of x as x approaches c must also exist, and these two in number 1 and number 2 are equal. So if these conditions are satisfied, f of x is continuous at x equals c. Okay, what if we have this function f of x equals 2x squared minus x plus 4? Is this function continuous at x equals -2? So for condition number 1, let's check if f of c exists. So f of c is, our c here is -2. So we will have f of -2 is 2 times -2 squared minus -2 plus 4. That will give you this one. -2 squared is 4. 4 times 2 is 8. Minus -2 is plus 2. And copy plus 4. So 8 plus 2 plus 4 is 14. F of c exists. Number 2, how about the limit of f of x as x approaches c? Since this is a quadratic function, we already had a theorem that if the function is quadratic, f of a limit of f of x as x approaches c equals f of c. So we can already satisfy the two conditions. So yes. How about at x equals -1? So solve for f of c, that's f of -1. So 2 times -1 squared minus -1 plus 4. So -1 squared is 1 times 2 is 2. Minus -1 is 1 and copy plus 4. So 2 plus 1 plus 4 is 7. So f of -1 is equal to 7. So it exists. And since this is a quadratic function, then a limit of f of x as x approaches c is just the same as f of c. So it's also 7. So yes. At x equals 0, f of 0 is 4. So the limit exists. How about at x equals 1? Yes. And that is equal to 5. So yes. But actually, this function, since this is a quadratic function, the graph is a parabola without any interruptions. There's no hole, there's no jump, there's no asymptote. The function is actually continuous at any point or at every point on the number line. So we will say that this function is continuous everywhere. How about this rational function f of x equals 2x over x plus 3? Is this function continuous at x equals negative 3? So let us solve for f of c. That's f of negative 3. So if you will substitute negative 3 here, you will have 2 times negative 3 is negative 6 over negative 3 plus 3 is 0. So over 0, negative 6 over 0 is undefined. So there is no f of c. So since there is already one condition that is not satisfied, then we are sure that the function is not continuous at x equals negative 3 because it does not satisfy condition number 1. So you don't need to check 2 and 3. But if you wish to check 2 and 3, then number 2, the limit also does not exist. And of course, number 3 will not be satisfied. How about at x equals negative 1? So if x is negative 1, we will have f of c, that's f of negative 1, 2 times negative 1 over negative 1 plus 3. So 2 times negative 1, that's negative 2. Negative 1 plus 3, that's 2. Negative 2 over 2, it's negative 1. So f of c exists. And since this is a rational function, the limit of f of x as x approaches c is just equal to f of c for every x in the domain of the function. Meaning to say, for any value of x except 3, the function is continuous or is defined. So yes, at x equals 0, yes. At x equals 1, there's an f of c. The limit is, okay, yes. So actually, this function is continuous at any x value, x just except for negative 3. So continuous at any real number except negative 3. Let us have another example. What if f of x is equal to 2x if x is less than 2? And f of x is equal to x plus 1 if x is greater than or equal to 2. So, is this function continuous at 2? So, at x equals 2, f of 2 is f of 2. Where is 2? Less than 2 or greater than or equal to 2? Of course, it's greater than or equal to 2 because 2 is equal to 2. So, we need to substitute in x plus 1. So, this is going to be 2 plus 1. So, that is 3. That is f of 2. How about the limit of f of x as x approaches 2? If we are from the left, limit of f of x as x approaches 2 from the left, you have to use values less than 2, like 1.9, 1.99, 1.999. So those values are less than 2. So you need to substitute here. So you will have 2 times 2, that is 4. So the limit of f of x as x approaches 2 from the left is 4. How about from the right? So if you're from the right, you have to use values 2.01, 2.001, 2.00001, and those values are greater than 2. So you have to substitute here at x plus 1. So 2 plus 1 is 3. So the limit from the left is 4. The limit from the right is 3. These two are not equal. Therefore, the limit of f of x as x approaches 2 does not exist. So condition number 1 is satisfied. F of 2 exists. It's equal to 3. But condition number 2, the limit does not exist. So it doesn't satisfy number 2. So therefore, it also doesn't satisfy condition number 3. So at x equals 2, the given function is not continuous. So no. How about at x equals 0? X equals 0 is less than 0. So you have to substitute here. That's 0. F of 0 is 2 times 0 because that's 2x equals 0. And the limit will also be that one because we only have a critical number at x equals 2. So at other values of x, the function is continuous. So at x equals 0, it is continuous. At x equals 3, it is continuous. At other values of x, it is also continuous. Just except for just the x equals 2. At x equals 2, the function is not continuous. But for other values of x, the function is continuous. Okay, so that's it for continuity at a point. Please hit the like button, subscribe, and if you have questions, just comment down below. So see you in the next video. Bye!